Hello everyone, I am Dr. Millie from Erudite Chemistry classes, and today we are going to discuss the topic called ionization enthalpy. Most of the students find it confusing, but we will deal with this topic by taking the examples so that it will become easier for you to understand this topic. Okay, so let us understand first कि ionization enthalpy क्या होती है. What is ionization enthalpy? So here's the definition written. It says that energy required to remove an electron from isolated gaseous atom when it is in ground state. So there are some key terms here which you have to understand. First thing is we are taking that atom which is isolated, means it is not connected. Second thing, it should be in the gaseous state. Third thing is it is in the ground state. It is not about to react. So it is ground. It is not reacting, it is gaseous, and it should be isolated atom. It should not be bonded to make the molecule. So if this kind of atom is available and we are removing the electron from this kind of atom, so the energy required to remove an electron from the outermost shell of that atom, what kind of? Isolated, in ground state, and it is gaseous atom. So gaseous atom के outermost shell में से इलेक्ट्रॉन को निकालने के लिए जितनी एनर्जी required होगी, that energy is known as ionization enthalpy, and it is always delta Hi, that is symbolizing the ionization enthalpy. Definitely the energy is required, so this type of change will be positive. So always you will find that your ionization enthalpy will be positive in nature. So delta IH will be positive. What will be the unit of ionization enthalpy? Obviously it will be taken in kilojoules per mole. Now we will see what happens to an atom when an electron is removed from it. Okay, and what if I am removing one more electron from it? So we are going to see what happens when we are removing more than one electron from any atom. So I am taking an example of an atom which is X. I am representing the atom with the X, and if I am removing one electron from this X, so what will happen to this X? This X will turn into its cation, and this electron is removed, and the energy required for doing this is known as delta IH1, that is IE1. This means that this is the first ionization enthalpy. The energy required to remove one electron from the isolated gaseous atom, and that energy is known as first ionization enthalpy for that element. Now I am going to remove an electron from this ion which has already removed one of its electron. So let us see the second step of it, that is we are removing one more electron from it. So what will happen to it? This will lose its one more electron, and when it will lose one more electron, it will be a difficult task for removal of electron because already it has lost one. So the nucleus charge already increases because you have removed one electron, charge is increased, and again you are removing one more electron. So it will be a tough task comparatively, comparison to the first one. It will be tough to remove the electron. So do remember, this is ionization energy 2. Okay, so this is IE2, that is the energy required to remove the second electron one by one. Step by step we will be doing it. So what is happening? Delta IH2, and obviously this delta IH2 will be more than delta IH1. The reason behind, the first step mein to it was an atom which was neutral in nature, so you were removing the electron from the neutral atom. In the second step what you are doing is you are removing the electron from already lacking species. So this way we can have either IE1, IE2, or if I am removing one more electron to make it a tri-positive species. For an example, X2 plus I am taking, and I am removing one more electron from it. That means it is now tri-positive, and the ionization enthalpy in this case will be IE3, and obviously already you have removed two electrons now, so now this time again it will be more tough. That means delta IH3 will be higher than delta IH2 will be higher than delta I H1. But whenever we talk about what happens when X is converting into X3 plus by the loss of 3 electron, overall energy we used to take. We are not mentioning there in slots, that we are not mentioning step by step. We just find out the IE1, IE2 and IE3. We just total them out and then we give the ionization enthalpy to convert this atom into this kind of ion. So ionization enthalpy is the sum of all the energies required for the various steps, that is step number 1, step number 2 and step number 3. Okay, now we will learn about the factors which will affect the ionization enthalpy. So if you are given two atoms and you are asked out of these two from which atom you can release the electron easily. So I am giving you the case atom number 1 and another atom I am giving you here, that is atom number 2. So atom number 1 and atom number 2 I am giving you, and the question is I want to remove this electron from this atom and I want to remove this electron from its atom. So out of these 1 and 2, which will show higher ionization enthalpy, means किसमें से इलेक्ट्रॉन निकालना ज़्यादा मुश्किल होगा. So it is very obvious that size of the atom will definitely affect the ionization enthalpy. How it is going to affect? Because in this case, atom number 1, this electron which has to be removed is very close to the nucleus. Obviously, the pull of the nucleus is higher than in that case where it is somewhat far. So in this case, it is not that easy to remove the electron. Hence, you will need more energy to remove the electron from its outermost shell. On the other hand side, this nucleus is somewhat deep because the atom is bigger in size, and now it becomes easy to remove this electron because the forces of attraction between the outermost shell electron and the nucleus will be comparatively less. So we can say, in nutshell we can say कि जैसे जैसे साइज बढ़ता जाएगा, more is the size, easier will be to remove the electron and lesser will be the ionization enthalpy. Is it clear? So what we can say is, when we are talking about the size of the atom in a particular group, so if I am moving up to down in a group, ionization enthalpy decreases because the size is increasing. Hence it becomes easier to remove the electron from the outermost shell because the distance of outermost shell from the nucleus increases when we move up to down because of the increase in size. I hope it is clear. So let us see the next factor which affect the ionization enthalpy. Second factor which influence the ionization energy is charge on the nucleus. So what is the second factor? Charge on nucleus. Means if the size is not changing, then see what is changing there. If the charge is changing but the size is not changing, more is the charge, more will be the ionization energy. The reason is simple. More is the charge means forces of attraction which are attracting the outermost shell electron towards itself will be higher, and more is the charge means it will not be easy to release the electron. Hence you will require more energy to release that electron. So here we have the atoms from the second period. These are the charges present on them, and these are the ionization enthalpy, which are the energies required to remove an electron from the second shell, which is the large shell of these atoms. Okay, so can you see there the charge is increasing when we move from left to right in a period, because we are adding 1 and 1 electron to it and as well 1 and 1 proton to it, but we are not changing the shell. The shell is second because we are in a period and it is the second period. So can you see there, +3, +4, +5, +6, at every step the charge is increasing. So we are talking about what will happen to the ionization energy when the charge on the nucleus is increased. So you can see there the charge on the nucleus is increasing at every step. Now let us have a look to the ionization enthalpy. Can you see there it is 520, it is 819, 801. Every time the ionization energy is increasing. That is, जैसे जैसे the nucleus charge is increasing, the nuclear charge is increasing, more and more energy will be required to pull the electron from that atom because the force of attraction is increasing with the charge on the nucleus. तो जितना ज़्यादा पावरफुल न्यूक्लियस होगा उतना ही ज़्यादा मुश्किल होगा आपको इलेक्ट्रॉन को बाहर निकालने के लिए. But you might have observed one thing here. Can you see this? What is happening here? I was telling you when we move left to right in a period with the increase in the nuclear charge, it will be tough to remove the electron. So what is happening here then? यहाँ क्यों नहीं हो रहा है ये? What is the reason behind? That is the next factor which is going to influence the ionization enthalpy. So in general we can say if the charge is increasing, ionization enthalpy will also increase. But what is happening to them? So the charge is increasing but the ionization enthalpy is not increasing. So what a special case it is. So that is the third factor which we have to take care of. So first of all, before going to this factor, I am going to write down the configuration of these electrons so that you will understand that factor. So I am writing down the configuration of this beryllium 1s2, 2s2. Boron is 5. So the configuration is 1s2, 2s2 and 2p1. Now you have to see from where you are going to remove the electron. So you can see here that in case of the beryllium, I have to remove the electron from the s orbital. And in case of boron, I have to remove the electron from the p orbital. So what? I have not mentioned it now. So let us understand the next factor. So the next factor is penetration effect of orbitals. So what is penetration effect? Penetration effect we can understand like that we have 4 type of orbitals, s, p, d and f. Out of s, p, d and f, s is having lowest energy. The s which is having the lowest energy is very close to the nucleus. For an example, if I am talking about this nucleus and the second, suppose third shell or fourth shell I am talking about. So in the fourth shell there is s also, p also, d also, and in these orbitals the energy levels are different, and if the energy levels are different, obviously the closeness to the nucleus will be different. Means जो s होंगे वो इसके पास होंगे, p होंगे थोड़े दूर होंगे और d होंगे वो थोड़ा और दूर होंगे. In short, I can say that s orbitals are close to the nucleus, then p and then d and then f. So very far from the nucleus are f orbitals and very close to the nucleus are s orbital. That is why if you are trying to remove the electron from the s orbital, obviously they are deep, they are in touch with the nucleus, so it is not easy. And if you are removing the electrons from the p orbital, it will be comparatively easier out of these two if the shell is same. So here you can see it is removed from the second shell. This is also removed from the second shell, but the difference is it is removed from the s orbital and this is removed from the p orbital. So it is easier to remove the electron. So if it becomes easier to remove the electron, the ionization enthalpy will be lesser. That is why the ionization enthalpy of the beryllium is more than the ionization enthalpy of the boron. So this change in trend of the ionization enthalpy, which is not following the charge of the nucleus wala step, this is due to this special effect. What is that? Penetration effect. I hope this is clear to you. Let us talk about the fourth factor, and the fourth factor is extra stability of the half-filled and full-filled orbital. Half-filled and full-filled orbital means we know that p orbital can have 6, d orbital can have 10 maximum and f orbital can have 14 maximum. This is called complete orbital, yani ki full filled configuration. We know that this is very stable, but apart from this, if there is p3 or there is d5 or there is f7, that is half filled orbital, and these half filled orbitals are also very stabilized. So you do remember, if these are the conditions, the electrons will not be removed easily because the atoms are already at the higher stability, so they will not lose their electrons so that they will get disturbed their stability. So let us see the example to better understand it. So here we have the example which will explain you this factor, that is extra stability of the half-filled and full-filled orbitals. Half-filled and full-filled orbitals are very stable and every atom want to be there in that situation जहाँ पे वो half-filled हो या full-filled हो. If you are trying to remove an electron from the half-filled orbital, it will not be easily giving you, so ionization enthalpy will be higher. So let us understand it by taking this example. Here is nitrogen 1s2, 2s2, 2p3. The configuration is 2p3. You can see here P is containing 3 electrons. Obviously P can contain 6, but here we have half-filled configuration. On the other hand side, oxygen is having 1s2, 2s2 and 2p4, and you know this thing that this is not half filled. So we are going to compare these two. Let us see what happens. Nitrogen may say, if I am removing one electron, what will be the next configuration of the nitrogen? I am writing it here, 1s2, 2s2 and 2p2. Okay, and what will happen to the oxygen? 1s2, 2s2 and 2p3. Okay, let us compare the ionization enthalpy of the nitrogen and oxygen. Whether this nitrogen will remove its one electron or not from the P3. As I have told you, they are extra stable. If we compare the first ionization enthalpy, that is IE1 of nitrogen and IE1 of oxygen. IE1 of nitrogen, if I am using, it will convert into 2p2, and nitrogen will not easily give its one electron because after this removal of electron, this will be not stabilized. It is already stabilized. So this will be a tough process comparative to this process. The easier process will be this one because after the removal of this one electron, this will get stabilized. So for the oxygen, it is easy to lose this electron because after the loss, it will be comfortable. But here in this case, nitrogen will not like to lose its electron because it is already in the stabilized state. So you can understand this thing very way that IE1 for the nitrogen will be higher than IE1 for the oxygen. Isn't it? Isn't it? So let us talk about the another step. If I am trying to remove one more electron from this N plus, so what is happening? It is going to remove one more electron and will convert into N2 plus, and this is called IE2. And same thing we are doing for the oxygen also. We are removing one more electron from this lacking species. So what is going to be formed? O2 plus by the loss of one more electron, and this ionization enthalpy is called IE2 because to remove the second electron, the energy required is known as second ionization enthalpy. Now you just guess which out of these two, IE2 of oxygen or IE2 of nitrogen. This is nitrogen, this is at P2 state, but now the oxygen has reached to its stable state. Now that is why the oxygen is not going to lose its electron easily. In the first case, it has removed its electron easily comparatively because that was not stabilized that time. But this time it is now in the stabilized state. तो अब ये इलेक्ट्रॉन आसानी से नहीं देगा. तो ऑक्सीजन के लिए ionization enthalpy will be more and nitrogen के लिए ionization enthalpy will be comparatively lesser. So we can compare the IE2 for oxygen and nitrogen like IE2 for the nitrogen, IE2 for the nitrogen will be less IE2 than the IE2 for the oxygen. Can you understand this? IE2 for the nitrogen will be lesser than the IE2 for the oxygen. So these are the factors which influence the ionization energy of any atom. So I hope we have discussed all the factors which influence the ionization energy of an atom. Do practice for it, do many examples which are given in your syllabus. That will make it more clear to you to find out the ionization enthalpy. One thing you have to remember is ionization enthalpy is taken successively, that is one by one the electrons are being removed, and when we talk about one by one, both the processes are separated, and when the one electron is removed, the energy required is called first ionization enthalpy. When you remove the second electron, then the energy is required is called second ionization enthalpy, and total energy, total ionization enthalpy, yeah, overall ionization enthalpy to convert this N into N plus 2 will be the total of IE1 and IE2 required for the both steps. So it will be a sum of. So I hope this video will make it easy for you, and now you are understanding what is ionization enthalpy and what are the factors which are influencing it. Thanks for watching.